Thank you, Justine. Thank you all for being here. It is my first time at the BayLAN, so it's a pleasure for me to meet this audience. Nevertheless, at ACT and at ACT Next, we've been working on similar type of questions as probably many of you here in this room do. I would like, before I start talking about some of our work, I want to emphasize that I'm not an island for sure. Actually, I'm the senior vice president of this group, so the work that is being done here is definitely with many people. I want to emphasize the work of Steve Polyak, Michael Udelson, Kurt Peter-Schmidt, Benjamin Donovich, and then in the background there are other colleagues at ACT who have been working on different parts of this project, and I will point that out as we go along. So in my presentation today, I will talk in general about what it means to be at the crossroads. We are now embracing, or maybe hating, the technology in the classroom, the technologies in our lives, and we close sometimes our eyes with respect to some of the issues that the previous speaker pointed out, like privacy, consent, in order to get the benefits of some conveniences. What do those mean for the classroom, and what is our job as scientists and researchers to work on that? Before I start talking about the application itself, I will talk a bit about what ACT Next is. ACT Next is an innovation hub at ACT. And ACT is the testing company, so some of you may have taken the ACT. It's quite common in the Midwest, so I don't know if here on the West Coast it's common or not. But what we try to do is we started in 1960 as disruptors, as a company. This is where the machine for reading automatically those bubbles on the test sheets was invented. And also as a college admission test was a revolution at that time, because the idea was, let's create a test that is more aligned with the curriculum as opposed to a test that is more geared towards identifying someone's potential aptitudes. So from those two perspectives, ACT started as a disruptor. And here we are, 60, 70 years later, where ACT is building again an innovation hub and trying to change the educational experience, hopefully for the better. In particular, in my group, we are focused on computational psychometrics, and this is at the basis of a lot of our activities. I introduced the concept of computational psychometrics at Machine Learning Conference, ICML, in 2015, to denote and express and introduce a new vocabulary for the type of work we've been doing. Because otherwise I had to say psychometric theory with machine learning, with data mining, and stochastic processes, by the way. And that was a bit too much. So I've been looking for a good word to describe what was actually that my team was doing. At that time I was at ETS, so that was a while ago. So this is the basis of what we do, which implies, of course, like everything in life, has some positive things and negative things. The positive things are that we are obsessed with accuracy, validity, reliability. And this underlies all of our work. The negative things could be, from some people's perspectives, for example, from the learning scientists, most commonly, could be that we might not include too often all the potential theories of learning. Not that we don't include it at all, but that we are less, we emphasize less the impact of theories of learning than the accuracy, validity, scalability, and the claims that we are making in our work. So with this, I will move along with the type of ideas and prototypes that we've been developing. So we start with acknowledging that in our world, in all parts of our world, the agents, the assistants, the robots are actually here. Our life is already impacted by all of this. We pose questions, we have reminders from different assistants, our sleep is being tracked, and we get feedback all the time, and so on. But what about the education? What is happening now in education? There are many classrooms that already have assistants working with them. And assistants and robots don't necessarily look like a robot. They don't necessarily have a body. But doesn't mean that they are not a robot. What makes a robot or an assistant is a synthesis of multiple algorithms that do specific tasks in an intelligent way. What does intelligent even mean? Intelligent means probabilistic. That's what intelligent means. Intelligent means that that there is a process by which a model integrates existing information from training data, from other sources, prior information, and according to some laws, mathematical formulas, will be updated in a way or another. And then it spits out a probability, and that's the learning part. It gives you a probabilistic result. So if you keep that in mind, that robots don't necessarily have a body, and that what they do will give us probabilistic results with respect to different things that we ask them to do, we program them to do, we can see how fast they are learning. And I think this is another thing I want to emphasize here. And for this slide, I want to separate, and this is really just my attempt for this presentation. It's not particularly deep, and I'm sure people who have been working on digital assistants may have different classifications. But for those in the classroom, I would separate them in good assistants. Good assistants would be like intelligent tutoring systems. You have one intelligent tutoring system that is teaching you math, and is doing that really well. That's a good assistant. Well, then the next level is a more accomplished assistant. A more accomplished assistant is one that has a kernel of models that can be applied to different domains. So it can teach you math, but it could also teach you language, could teach you science, teach you something else. Examples of those are IBM Watson, and our own prototype aims to be one of those. It has multiple applications across multiple domains. Of course, there is always place for better. That would be the really sophisticated assistant. I'm not aware of any of that in real life, but I think we can dream about the holodeck. How many of you know what's the holodeck? Okay, more than at the last audience. So the holodeck showed up in the Star Trek, a really old series, and it's that special virtual room that you go in and you can learn whatever you want to learn, and we are aiming for that. And when I say we are aiming for that, again, please don't take it literally. I don't necessarily mean a room, and I don't necessarily mean a body of someone who would be walking with me along all the time. It can mean many things as long as the function is there. And this intelligence, the probabilistic behavior is there. So what does it mean for educators? Well, obviously, there is a lot of the impact is quite strong. And if people are not aware of all of this, they should. Because they have to be co-designers of these elements. They have to be part of this conversation. They also can engage students in new and deeper ways. And they can, with the help of assistant, can manage heterogeneous classes. For learners, we have personalized instruction, support to achieve their goals through recommended pathways. We can give the learners more agency, and we can use the assistant to support the learning and the progression in 21st century social interactions, collaboration, sharing, and so on. Also, most of these assistants have to be mobile, have to be where you are. And if that means they have to be on your phone, then be it. They have to be on your phone. And they need to give immediate feedback and hopefully increase the engagement of the students. What is our role? What do we need to do? Our job is to develop the infrastructure, the invisible infrastructure. And we need to work with the educators, and we need to ensure that the skills are actually based on learning theories and psychometric theories. So we cannot just leave it all to the computer scientists. because there are aspects of the process of learning where teachers and educators need to have a say in the development of these tools. So let me move further ahead and talk about an example of such an assistant that we created in my team. It's an app. It's a mobile, so it has the features that I mentioned before, and it provides support in multiple domains. It provides support in academic domains, math, language, science, but also we've been working on social emotional learning, identification, diagnostic, and support. And in the future, we will have other factors for which this system could provide support. So it helps students. They can improve their scholastic performance, prepare for the test, engage in self-discovery. So we also have elements about the career that they might like, what personality traits might possess. And we provide them with diagnostic, feedback, personalized educational resources. And I have here a video, so I know usually this can be a problem, so let's see. It is Dutch, and it tells me that something proxy server is not available. If we can, we'll skip this one, but I would really like to show you the next one. I have another video. So you are going to hear Steve Polyak present, two minutes, present this app. And then I will talk about what is underneath and how the learning analytics.
So here we are at their personalized home screen. And from here they can get access to their progress information. This progress information was built as a diagnostic model from a range of different sources. For the academic areas, as we can see, the holistic framework here has a breakdown of a hierarchical arrangement of the subject. So we can go into, for example, operations, algebra, and functions. We can see an overall rating for the user here based on the stars to the right. And to the left we have a count of how many of these resources they've actually interacted with so far. So for example, for this user we might say we'd like to practice ratio and proportions. What we can see here is for each area at this level of the hierarchy, they're able to select to skill up using a learning resource or take a quiz in this particular area. When users select the Skill Up button from the home page, users are given a learning resource aligned with their biggest diagnostic need based on their diagnostic model. So in this case we have one on graphing and graph transformations. They're able to watch the video here, indicate if they like or dislike the video, and then continue to progress along to the next selected resource from their diagnostic model using the Skill Up button. In addition to this, the users have various activities that they can interact with. One example is the Major Fit component. In Major Fit, what users are able to do is select a particular major that they might be interested in, let's say for example engineering, and then indicate either what their current score is or their aspirational ACT score, as well as their current high school GPA. What they're given in here basically is a percentage of earning B or higher in college, a percent that they're going to return for a second year of college, as well as being able to graduate college in 4 years. So in addition to having resources recommended directly to them, they can also search for resources based on a particular interest area. So let's say, for example, geometry. The search results basically give them ability to page through and select a particular resource that they would like to interact with.
So what you saw was an overview, very brief overview of how this app works. And I want to emphasize that the OpenEd resources that was called there in this app. So this was also developed by the OpenEd company who was bought by ACT a few years ago and is part of the ACT complex offering for learnings. So now what is behind it is, okay. It's working. So again, I mentioned before, computational psychometrics is at the basis of what we do. What we mean by that is, again, this blend of theory with data-driven algorithm. That's the key. And when I say algorithm, there could be multiple things. There could be data mining or machine learning, various machine learnings, or could be different time-dependent modeling approaches from time series to stochastic processes. The idea, though, is that you collect this telemetry alongside with the responses eventually either in a learning environment or an assessment environment. You extract different features, you construct and estimate the higher levels, and then you go back to the first cognitive models with which you started, presumably. And then you iterate and you learn and improve your models as you do that. So this is the full concept behind the app. We are using the theoretical framework. So again, the theory, it's important for us. In our case, I only have 5 minutes. Jeez. Surprise. So we have an ACT framework which is referring to different constructs, and this has been developed by our colleagues in research over the past 10, 15 years. And we call it the missing link concept because we have the data, primarily ACT test data, but also test prep, with which we wanted to start. We have the educational resources and the learning data from the open ed, but what was missing was the 3 and 4 there, the diagnostic and feedback model. And we started with traditional psychometric approaches with cognitive diagnostic models, but then we started to look into learning models such as BKT, Bayesian knowledge tracing, or other models. And then we moved into learning, not moved into, but brought to the learning analytics tools. And we pretty much blended all of these approaches into one. And we call it the cognitive dynamic CDM, so Dynamic Cognitive Diagnostic Model. That's the name of it. The technologies that we use for the app are based on React Native, so I will skip that. And the key technology here is the recommender, the diagnostic and recommendation engine. And this is an architecture of how this works. So you generate the evidence as a learner, and we generate diagnostics based on the evidence that we have. And then through the API, we generate specific recommendations for each student. And then the student has the opportunity to review the resources and provide additional evidence and so on. What makes our approach different from most of the computer science-based ed tech companies out there that provide learning systems is that we are blending the say the ELO algorithm or other models that are traditionally from the machine learning universe with the psychometrics. And these were all the models that we actually look at them. And I have another table that's probably is more useful. But primarily for the first round, we use the ELO algorithm for making recommendations, and we mix it with psychometrics. So these were all the models that we look at, and we classify them into psychometric models. Psychometric models are great if you don't have a lot of dependencies in the data for a one-time measurement like tests. Psychometric models are really great for that. Then you have rating schemas that are not really models. You just rank and compare, like the ELO algorithm, but we also have a new one developed by one of our scientists, Gunther Maris, the earnings model. And they can have different variants. And then we have the learning models, which are very familiar to those of you who know the educational data mining community. So we decided, we run all of them, and here you see here some pluses and minuses for all of them. And for our first run, we went with a ELO variant. And here is the variant that I'm talking about. If you are very familiar with the ELO model and something is really wrong with that formula there, really, really wrong. Let me see. So if you are familiar, do you know what an ELO algorithm is? How many of you know? How many heard of the ELO? Okay, thank you. So the ELO algorithm is what has been put in place for chess players in the 50s. And the idea is how do you know, the chess players have a number in this world. It's a ranking number. That ranking number is based on an ELO algorithm. And when two chess players play against each other, the estimated ability is being estimated each time and updated. And this is what we have here, just that instead of playing person against another person, you have person playing against another skill. So that's the ELO part that we are using here. In addition to that, we use a psychometric approach to expand those skills, and that's the LLTM model, which is the linear logistic test model that was developed by Fisher initially, which is expanding the difficulty of a skill, or of a skill in this case, linearly. So we have skills and we have sub-skills, and then we explain that difficulty and expand that linearly. Unfortunately, this particular formula is really, really bad. But it works quite well for us, and this is how it looks again for now. Don't even look. It's all bad. I don't know why, but it's really bad. What is supposed to be there are the updating formulas that are common in the ELO system, with the psychometric part included in there. And what you see here are the attempts and how the updates are taking place for different sub-skills. That's the representation there. So so this is what happens under the hood. The student doesn't see any of that, of course. What the student gets to see is this. So they are getting feedback as in stars, 1 to 3. And we are doing this for the ACT Academy, which is a free product that helps kids from everywhere to prepare for the ACT test, free again. And this is where we run our experiments, which was a really good test bed for us, because we ran over 150,000 students with over 3 million quizzes. So when we say that, well, we have a probability of X, actually that probability is quite stable. And then in addition to that, what we did was to add, and I want you to see this video, let me see, and then I finish, promise, assuming I get this to run. Can you, I got it here, but so in addition to developing all that, we want now to work with making it a real
so far
assistant.
is the English language version. By simply going over into the settings of your phone and saying, for example, that you want to change your language and region to, instead of English, if you wanted to change that, for example, to Spanish. Once you do that and you relaunch the app will actually render all of its resources and strings and menus in the corresponding language, assuming that we have a language bundle for that. So that could be Spanish, French, Chinese, and so on. So the app has been fully internationalized for that as well too.
So to make it a real assistant, we want
just
voice
a few things before we get started.
And this is machine-based.
In the progress area, you will be able to review what ACT knows about your abilities based on your ACT test results, work keys assessments, and Tessera evaluation. In the activities area, we will provide you with a personalized set of learning resources to help you practice the skills aimed at improving your ACT score.
Today we will be learning how to compute the area of a circle.
اليوم سوف نتعلم كيفية حساب منطقة الدائرة.
Gravity is a force that attracts objects towards each other. Gravity only becomes noticeable when there is a really massive object like a moon, planet.
الجاذبية هي القوة التي تجذب الأشياء تجاه بعضها البعض. تصبح الجاذبية ملحوظة فقط عندما يكون هناك جسم ضخم مثل القمر أو الكوكب أو النجم.
So what we are trying to do now is to take it to the next level, to create this image of the holodeck. I told you that that's what we are aiming to. So we had so far only through visual and text. So now we want to expand that to multiple languages and to text to voice. So these are the new directions of our work, and we are trying to do that at scale. So again, it's not just for a small number of items or a small number of people. We are really trying to reach to 100,000 of students, which is what we already did for the diagnostic model, for the RAD model. And these are the technologies that we've been using for these purposes, and these are some of the metrics that we've been looking at, and we're actually still writing those up. How to evaluate whether our system shows the efficacy that is necessary. And these are interesting. It's a nice visualization because you can see after a particular sequence of activities how eventually the area of mastery has expanded by using these tools. So I will skip the future work because I already mentioned some of it, but what I want to say is pretty much the last slide, which is very much related to what we heard in the previous presentation. We need to keep that in mind, that we should not do harm. The Hippocratic oath is necessary for all of us. And the technology, even if not fully baked, is already here. It's only a matter of refinement and time to actually have all of these tools ready in the classrooms. And we share, you as well as we share this responsibility of working together. So thank you. I hope I gave you an overview of some of the work that we do at ACT Next. Thank you.
We have a few minutes for questions.
Yes, there is one in the back.
Yeah, Alina, thank you very much for your presentation. When you were showing the demo of your product, it was interesting that the student had access to specific information about which major they would be more successful in. That information was presented in terms of percentages. We all know that making informed decision is a huge gap nowadays, and that these could empower students to make decisions within a system. Taking into account that the system nowadays is unequal in terms that not all of us have access to the same opportunities, and that some of these prescriptive analytics can actually prompt students to make decisions that are going to make them perpetuate their social class, career, status. How do you think that this tool could empower students through agency? How can this tool help them actually to move forward, not to the place where they will be more successful at, which is their previous background, but actually to achieve that career turning point or that success that we're achieving learners to do in this unequal world?
Yeah, good question. And actually we did hear that type of question before. First of all, it's actually even more basic than that. We are talking about a mobile application. So we assume that people have access to internet, and that's apparently still a big assumption even for the United States, or especially for the United States, I should say, because actually a lot of other countries, at least in Europe, do not have that problem anymore. So yeah, that's an assumption that we make, and it's unfortunate. I believe that when I talk about responsibility, it's all educators and scientists, but it's also the rest of the society to make sure that, for example, there are resources available for schools to have broadband internet access. So that's one aspect. What you are saying is also a bit deeper than that. What if a student received these recommendations, the student maybe has not been doing that well, and this recommendation may not optimize the potential of that student, but actually are to align with the demographics of that student. Fair point, and this is actually where we are looking at. I talk about those RAD metrics. So one of the things we are looking at is to see whether we make significantly different recommendations for students who are able, so conditional on ability. So we are looking now at students of different abilities and how, and perhaps different demographics if we have that data, and how the recommendations are being made for them. It's a good question, and I would encourage all of you to think about that. It's true for all of our, including for our classrooms, brick and mortar classrooms. Yes, Lihua. Oh, I'm sorry. I think sorry, he got the microphone.
It's actually a follow-up to that question. Like, what do you think is the value? Like, I think I remember saying something like, probability that like you finish your degree, like go enter to university. What do you think is the value of providing like a really low probability, like say to a student, you have absolutely no chance of? Mm-hmm. Do you think that's useful?
To be very honest, I think so, but I'm in minority. Yes. I think that, but you are absolutely right. That was another feedback that we got, that we should change the language there. So yeah, we will change the language from saying you have no chance of getting into that school to, you really need to work a bit harder if that's really what you want, and so on. So I'm not the best person to come up with the right language there. But yeah, I think too many people are told that they can be everything in life, including president. So I think that that's appropriate, that at some point in time they will also hear that perhaps they need to work harder. But we need to take care of the language. We also need to be careful with the idea of probability, because what you see there is also a probability, and not everyone can actually understand the probability. So if I tell you that your probability is 0.2 and you actually make it at Stanford, I was not wrong. I only said you had a really low probability. But that's a way of understanding what the probability means. So people need to understand that as well, and perhaps that with something we could have some language describing that.
Hi.
Somebody else again has the microphone.
I thought this was really interesting. Thank you so much for coming. My question is along the same line. Whenever you do user testing on your product, how do you determine that the feedback you're providing to the student and the recommendations you're providing are feedback that they actually understand and can enact upon?
So that's a good question. We are looking now at efficacy. So these are exactly the questions that we investigate. We want to see how much better they get based on the recommendations that we have. And in our case, I mean, we are a bit fortunate because for most of these students, we have an ACT test or pre-ACT as a pre-test. And then they go through this learning environment, that's the ACT Academy, where we make these recommendations, and then most of them will take the test again. So it's almost a natural pre and post test there that allows us to investigate the efficacy of what we offer. The only disclaimer I will put in there is that it takes more than just a good psychometric and technology to create that environment, and we depend on what are the instructional tools that are included there and how good those are, and so on. I mean, we do our best to select the best among those, but are they the best in an absolute sense? That's something to be debated. And of course, philosophically speaking, you could say that even in real life with a human teacher, you might not get the best in an absolute sense. So yeah, we are working on those. We are fortunate to have the pre and post embedded there, and so far it does not look bad. I mean, quite promising.
Last question.
Hi, Alina. Thank you for the work, and I applaud for you and your team did this product. It's very great. But I have a question that may be different from the other people. So I see that you use model like ELO and 1PL model and learning map, all those models. I bet you must, you and your team considered carefully about how to select the models. So I want to ask you, I was work at CPB. Of course, it's not there anymore. But that time they have great product. Like their 3PL model, like a partial credit model. Those, and I think they give better estimation than 1PL model, and also like a CDM model, they are discrete model. But why don't you use like a continuous model, like a multidimensional model? Because all different content, they're connected. Why don't you use multidimensional model or use more complex model, like a 3PL model, or you can go polytomous scored item and that? So same.
That's a good question. The main reason for that is that I mentioned before, even complex models like MIRT are static models. They do not take into account learning. And you have here a time dependencies that's going on, and they can't deal with that by themselves. So you need a learning model, and for our first round, we chose the ELO algorithm for that learning part. We only use the LLTM because of its particular features of expanding the difficulty of the skills in a linear form. Should we use a more complex model for that purpose? We have not seen the reason for that because the main part is the ELO algorithm, is not so much the other side. So that's why just an MIRT by itself, it will not work here. It won't do a good job because of the dependencies over time.
Yeah, so for the MERT model, you can build up connect all the level together, like building on time.
Well, yeah,
so
but you assume
together.
that the theta is, even those multiple dimensions, that they do not change. It's a stationary model. MIRT is a stationary model. You need non-stationary, stochastic type of model for that. We can talk after that, but we did look into it, and we don't think that that's a good model for it.
Thank you.
Thank you so much. Very interesting discussion. We've had it in our company a lot as well.
I believe all people who do work in psychometrics, they start there. They start with the traditional CDMs, and they start with the MIRT, and we did that too. Actually, we started with CDMs. Traditional psychometric CDMs. Those couldn't scale up. They were completely unstable. We couldn't run 100,000 students. We couldn't obtain convergence for the parameters for more than perhaps 5 to 8 subskills. So it was a disaster. So,
okay.
Yeah.
Thank you so much. Let's go on to the next speaker.
Thank you.
Thank you.